Hi, and welcome back. In this next lesson, we're going to talk about an option you have, which is to deploy vSphere with Tanzu, but not use NSX-T. So instead, we're just going to deploy vSphere with Tanzu on top of our existing vSphere distributed switch. So let's go ahead and explore a little bit about this. So what we want to achieve in this lesson is describe exactly what does deploying it on a virtual distributed switch mean. What are going to be some of your ramifications that you need to consider? If we're not going to use NSX-T, then we have to have the ability to do load balancing. We're going to describe the load balancers that we would be using in this case. We also are giving up how we're doing our normal putting each namespace in its own NSX segment. So we're going to need to explore this new construct called workload networks. We're going to talk about identifying some of the requirements that are needed if you want to deploy vSphere with Tanzu on top of the vSphere distributed switch. And we're going to talk a little bit about what that topology looks like. Finally, how would we go about and actually enable the feature? So let's go ahead and get started. From this picture that we saw earlier with using vSphere with Tanzu on top of NSX-T, it's a very close to the same picture, but we're missing one component here. If we're going to be using vSphere with Tanzu on top of distributed switches, we no longer can use vSphere pods. Okay. Our vSphere pods before were running as an option when we did vSphere with Tanzu with NSX-T. We can't use our vSphere pods when we're deploying on top of a vSphere distributed switch. We could still up here use our TKG Kubernetes clusters, and I could have multiple of them. We're going to talk about using the Tanzu Kubernetes grid service in the lesson coming up shortly. So if we wanted to contrast the two features to each other, when we're doing vSphere with Tanzu and NSX-T on the left side versus using it with vSphere distributed switches, obviously we're using two different networking stacks here for our first bullet. We still can do TKG grid service. However, you notice the pod service is absent when we use it with the vSphere distributed switch. For some of us, that might not be a big deal. We still have a network service. However, the networking service over when we're using it with the distributed switch is we've got to use something else for our external load balancer. Don't worry, we're going to provide it for you. We still have our storage service that we went through earlier, the ability to use the CNS that plugs into the CSI and to be able to do persistent volumes and persistent volume claims. That's still there. But we also are missing the registry service. Okay. Now there is options you can use over here for the registry service, but it's not a bundled, embedded, click a single button and turn it on that you could still deploy Harbor, but you're going to have to go through some additional steps. So let's focus on some of these aspects over here. Let's go ahead and dig in and get a little bit deeper. The external load balancer is going to be this additional component you're going to need to plus add to your existing vSphere environment. Now, we assume most of you already have a vSphere environment if you're taking this course. So you've got your existing vSphere environment and you're saying, okay, what can I do without making a lot of additional changes, and I'm just running core vSphere? Can I go ahead and do vSphere with Tanzu on top of it? And the answer is yes. You would do it and you would have to deploy manually this additional load balancer. That would give us the green go light to move forward with vSphere with Tanzu. Now, when you do this feature, contrasting it to doing it with NSXT, both of them are going to result in these 3 supervisor control plane VMs being deployed. However, when we do it on top of a vSphere distributed switch, we're no longer going to be plugging inside here the NCP that's going to be running. Instead, we're going to install these additional pods that are going to be running on each of the supervisor control plane VMs. And functionally, between the net operator and the load balancer API operator, we're going to get the same functionality that we got when we put the NCP inside there. On your supervisor control plane VMs, when we're doing our setting up of workload platform, we're going to have to give it some information. We're going to have to tell it, hey, I'm deploying this on a vSphere distributed switch, and this is my load balancer type that I've deployed already for you. Here's how you reach its API endpoint. Here's the credentials to log into that load balancer. And here's the virtual server range of IP addresses as I try to consume more of this load balancer. In other words, making additional virtual servers. Where would he get his IP address from out of this specific pool? So each of your supervisor control plane VMs are going to have, we call it a representation of the external load balancer. You could kind of think of it as just the details that you need to connect to it and talk to it. And we're going to be programming it via its APIs to instantiate new instances of the load balancer. Now, as of this version of vSphere with Tanzu running on vSphere Update 1, the only external load balancer that we're supporting is the HA proxy. Now, we're going to give you the OVA that you would use to deploy with it, and it's covered underneath your license fee. That HA proxy VM that you're setting up does have a control plane API endpoint that the supervisor control plane VMs are going to be able to talk to it to say, I need to instantiate another load balancer, or I need to do something. And when we say instantiate, it's the virtual server. So we're using one VM, but it could have multiple IP addresses attached to it each time we want a new load balancer to load balance to my workload or my pods. So that virtual server IP range is what you're defining, and you're doing that during the setup when you're enabling workload platform, which you'll see in the slides coming up. Also, when you're doing vSphere distributed switches, instead of using NSXT, you're also going to have to create these additional objects called workload networks. And what a workload network simply is just a definition that's going to point back to a specific distributed port group that you're going to map. And this mapping is being done via the definition of a workload network. That workload network is going to define an IP range that we're going to be using across that layer 2 segment. So you can go ahead and define numerous workload networks. So the workload network is supported by the distributed switch port group. You're going to need to define an IP range. That's going to be the range of IP addresses that we're going to be using for anything that we attach to that network. We're going to need one of those workload networks defined as the primary. The primary workload network is going to be the network that our supervisor control plane VMs are going to be plugged into. Now, Those workload networks are going to be consumed in two different areas. One, as I already said, it's going to be used by your supervisor cluster, and that's where your supervisor control plane VMs are going to plug into. You can also, and you will be, using those workload networks and attaching a workload network to a vSphere namespace. So we're still using the vSphere namespaces that we've already covered. But now when you create a vSphere namespace, and we see that you're creating that namespace on a vSphere with Tanzu cluster that is using vSphere distributed switches, we're going to we're going to require some additional information from you. And one of it is we're saying, oh, this is a namespace that's not going to be running through NSXT. So you're going to have to assign to that namespace a workload network that's going to be matched to it. You can only assign one workload network to that namespace. Anything that we deploy now in that namespace is going to be getting IP addresses that you've defined in your workload network. What are we going to be deploying in these namespaces if we can't do vSphere pods? You're going to be deploying your Tanzu Kubernetes grid clusters inside those namespaces. The other way that we can use those workload networks is over here on the supervisor cluster, and that's where your supervisor control plane VMs would be plugging into that specific workload network, as well as the HA proxy load balancer is also going to be plugging in there. We'll give you a topology picture in a few more slides. So we've been going at this for a little while now. Why don't we, this is a logical spot for us to break. Go ahead, take a break, stretch your legs, and when we come back, we'll take a look at a network topology that hopefully will help you better understand the things that we're discussing here.